All right. Hi, everyone. Today, we are going to be talking about the null space. Null space is basically the best. I don't know, this is one of my favorite sections to teach in the whole book. I really like it. But enough about that. Let's just go ahead and get down to it. So, the definition. This is another case of linear algebra where we're giving a new name and context to something that we've already been talking about. So in words, it's the set of all solutions to AX equals 0. So here we're talking about the null space of an M by N matrix A. So this is one way to state this definition. Another way, so here's the notation that we use, null A. It is equal to all of the vectors x such that when you multiply them by A, you get the 0 vector. All right, easy peasy. Solutions to the homogeneous equation. Let's look at an example. All right, is this vector u in the null space for this matrix A? So remember, being in the null space means that it's a solution to AX equals 0. So what do? We find AX and we see, is that 0? So let's go ahead and do that. All right. So let's see, 1, 0, 3, 0, 2, 6. Okay, 3, 2, -1. We want to multiply this out, and let's remember this is a 2 by 3. This is a 3 by 1. Those match up. So we can do this. We will get a 2 by 1 out of here. Okay, and let's think about this. So remember, we're going to go across and then down. Okay. And you multiply corresponding entries, right? So we're going to do the 1 and the 3. So that's 3. And then you add that 2, move over to the 0 and down to the 2. 0 times 2 is 0. And then over to the 3, down to the -1. It's going to be -3. Okay. So that's only part of this, but we're good so far. This is 0. Okay. So maybe it's the 0 vector. We need to go ahead and go do the other one as well. So now we're going to go across the bottom and down this same column. And we get 0 times 3, which is 0. 2 times 2, which is 4. 6 times -1, which is -6. So we end up getting -2. This is not the 0 vector. They would both have to be 0. So this is no, u is not in the null space. All right, checking to see if something is in the null space is as simple as just multiply the vector and the matrix together, see if you get 0. Okay, let's go ahead and talk about the following example. Now, you might want to find a spanning set for the null space. So spanning set basically means if I have a u in the null space, I want to be able to write u as a linear combination of vectors. Okay, so I want to be able to take that u and say, well, it's, something times this vector plus something times this vector plus something times this vector. And I want that to be the same for any u here. And let's remember, right, a times u has to be the 0 vector. So all we have to do here is row reduce, and then you're going to write your solution in parametric vector form. And those vectors give you your spanning set for the null space. All right, so let's write this down. And let's remember, right, what are we row reducing? Well, null space is AX equals 0, right? 0 null. So we're going to row reduce this matrix augmented by 0. Okay, so now we just got to row reduce, right? So we already have a 1 in the upper left-hand corner. So now I'm going to add these two these two rows together. So my first row doesn't change. And my second row, 1 and -1 gives me 0. 4 and -2 gives me 2. 5 and -1 gives me 4. -9 and 3 gives me -6. 0 and 0 gives me 0. And now I am going to do, let's see, I want to clear out this -2. So I'm going to do 2 times row 1. So that would be 2, 8, 10, -18, and 0, and then I'm going to add those together. Okay, so 2 and -2 gives me 0, 8, -3 gives me 5, 10 and 0 gives me 10, -18, here gives me, what, -15, and 0. Okay, and at this point, right, if I were in class, I would say, what do you guys want to do next? There are several options. But I am going to say all of these are divisible by 5, so let's multiply this by 1/5. Okay. All right. And also, let's notice here, all of these are divisible by 2. Let's multiply this by 1/2. That's very nice. 0, 1, 2, -3, 0. So 0 divided by 5, we get 1, 2, -3, and 0. What is gonna happen with these two rows? Well, let's subtract them. And I imagine several of you can see what is going to happen here, which is when you subtract them, you get a whole row of zeros on the bottom. Okay, and now we're not quite done. We're almost done. The only thing that we really have left to do is to clear out this 4. So what I am going to do is, let's see, we're going to use this pivot of 1 to do it. I am going to do -4 times row 2, and that's going to be 0, -4, 2 times -4 is -8, 3 times -4 is +12, 0, and we're going to add those together. Okay. And let's see, so we're going to get our reduced echelon form here. Our new row 1, 1 and 0 gives us 1, 4 and -4 gives us a 0, 5 and -8 gives us -3, -9 and 12 gives us +3, we have a 0 over here, and then we've got 0, 1, 2, -3, 0, 0, 0, 0, zeros over here. All right, so now we have this in reduced echelon form, right? Our pivots are 1s. They are the only things in their column. Zeros are all at the bottom. Everything is cleared out above the pivots. So we can go ahead and write out solutions in parametric vector form. Okay, and let's remember, right, the whole reason that we're doing this is it's going to give us solutions to AX equals 0, which is exactly the null space. All right, so let's see. 4 columns, 1, 2, 3, 4. So any solution that we have is going to be x1, x2, x3, x4. All right, and x1, so we have negative 3x3 plus 3x4. We move those over to the other side, and we would get, what, 3x3, oops, minus, let's actually remember to change the sign, 3x4. Down here we get x2, we move those over to the other side, so it becomes negative 2x3, and the negative 3 becomes positive 3x4, okay? And then x3 and x4, right, those have no pivots, so those columns correspond to free variables. All right, great. So now we have this written out. It's not quite in parametric vector form yet. What we have to do is split this up into the x3 part and the x4 part. So this piece, this piece, this piece are all going to go in a vector over here. Okay, and I'll just go ahead and write things all the way out. There's no x3 in the bottom part. And then let's do green. So this piece, and now this piece will be in this other part, negative 3x4, 3x4. Whoops, there's no x4 there, x4. Okay, and then what you do is each of these pieces has an x3, you factor that out as a scalar. Okay, so now you get that x3 out front, and what's left is exactly the constants that were in there. So 3, negative 2, 1, 0. Factor the x4 out as a scalar, negative 3, 3, 0, and 1. Negative 3, 3, 0, and 1. 3301. That's our course number. Yay. Okay, so what we have now is that every vector in null A looks like this. Okay, it's a linear combination of this vector and this vector. So let's call this u1, let's call this u2. And so those vectors u1 and u2 are the spanning set for the null space. Okay, so spanning set for null A is going to be these two vectors, u1 and u2. If you write it like that, you actually have to tell me what they are. Otherwise, you just got to write it all the way out. So negative, whoops. But you have to make sure you write it out correctly. That's the thing. Okay, so either this or this is totally fine. All right, so that is how you find out if a vector is in the null space. That's how you find a spanning set for the null space.